Hi, good day. I am Eniola. My team and I are here to discuss a topic titled Enterprise Architecture. Before I proceed, let me start with the breakdown of enterprise and architecture. Enterprise is a body of individuals who come together with common mindset in order to achieve goals and objectives. So an architecture can be said to be a framework, a design, or a pattern in which they use to construct a building. So merging the two definitions together, we can say an enterprise architecture is a framework, a design, a guide in which organizations create for them to achieve organization goals and objectives. So I'll be handing over to my colleague to explain further the components of enterprise architecture.
So my name is Abiodun, and continuing from where my colleague stopped, she was trying to explain about what enterprise architecture is. So enterprise architecture mainly focuses on two key factors. Number one, which is business strategy, and the second one is the technology infrastructure. And talking about this enterprise architecture, the strategy behind it is that all this information communication technologies cannot work except there is a brain behind it. So that's why there is always a factor of human input, that is the human beings being skilled enough to operate those information technologies. So going to the component of enterprise architecture, we have two components. Number one, we have the hardware and we have the software. So talking about the hardware components are the physical part of the computer that can be seen, and hardware components can be divided into four. We have the input device, the output device, the processing and storage. So talking about the input devices are the devices that send data into the computer. They are the technology responsible for sending data into the computer. Example of input devices: we have the keyboard, we have the mouse, we have the scanners, and etc. So talking about output devices, they are the devices that send data out of the computer. They are the one that displays whatever is being imputed in the computer. An example of such are our smartphones, the screen on our smartphones, monitor, etc. So the business strategy behind all of this is, even if a particular enterprise has all of this in place, if there is no human input, if they've not really skilled their employee who are supposed to operate behind it, there is no how they will be able to have a competitive advantage over the other organization. So the usage of this information technology and the skillfulness behind it makes an enterprise have a competitive advantage over the other. So talking about processing and storage, I would like my colleague to also continue from there.
Proceeding from where my colleague stopped, I would like to talk about the processing unit. My name is Otegbade Rotimi. The processing unit is also known as CPU, Central Processing Unit. It's a part of the body that helps with converting of information and calculations, mostly known as also a part of the system that helps transforming computer language into human understanding language. Furthermore, I'd like to talk about the Moore's law that spoke about how the storage process of the system is going to improve year by year, and which is true by now. The processing units have helped with making tasks easy for an organization. Example, like imagine an organization using a typewriter or willing to use a laptop. Works are far more easier than it used to be. And then we have different generations of computer. We have the mainframe, the supercomputer, the mini computer, the microcomputer, the laptops and tabs. With these things, works are made easier for everyone in an enterprise or an organization.
So my colleague has actually explained the processing unit. So where are this data stored? That takes us to the storage unit. Now, she actually talked about the Moore's law that states that computer technologies advances such as processing speed, the storage capacity doubles about every 2 years. So this shows that the Moore's law is actually applicable to the storage unit. Then we can say the storage capacities are measured in bytes. We have the kilobytes, the megabytes, the terabytes, and the likes. So The storage units can be divided into two. We have the primary storage and the secondary storage. Primary storage, example of primary storage is the RAM. The RAM serves, that is a random access memory. Then it serves as a temporal area for where data are being stored, and it is so volatile to the extent that once the computer system goes off, the data erases. Then and it's also a critical factor for computer's performance. Then moving to the secondary storage. Example of the secondary storage is the memory card, hard drive, hard disk, and the likes. The secondary storage unit is the area where massive data are being stored for organizational use. Then this business strategy aspect is where the organization employs the storage capacity that is easily accessible, that is safe, and can accommodate all data.
As my colleague said about computer hardware, I'd like to speak about computer software. It is a set of instructions, data, or programs used to process computer-specific tasks. It is a generic term used to refer to applications, scripts, programs that run on a device. Software as components. We have application software and system software. Application software is the most common type of software. It is the software that performs a specific function for a user, or in some cases for another applications. For example, having a Zoom meeting, you can either stream a Zoom meeting from a Google Chrome directly to a Zoom meeting, or you can either use Zoom app directly. So we have examples of computer software. We have communication software, the Zoom, Skype, and so on. We have Office Suite, where we have Microsoft Word, PowerPoint, and other PDF. We have music software, such as Spotify, Pandora, AudioMac, and we have web browsers too, Firefox, Chrome, and Opera Mini. On this note, my colleague will explain more on system software. Thank you.
Hi. So like my colleague earlier defined software, which he said software refers to a program to further operating used by a system, like a computer actually. So I'll be expanding more on system software, which is a type of software. We have two software, which are the system software and application software. My colleague earlier expanded on this application software, and I'll be talking about the system software. So what are system softwares? System software refers to the programs designed to run the computer application programs and hardware. Now what does this mean? It means system software refers to like the framework or the background or the foundation in which other applications are being run on. For example, it controls the operations of computer hardware and places or provides an environment or platform for all the other types of software to work in. So a good example of this is the OS, which is the operating system. And other examples include firmware and others. And also, system software handles the basic functions of the computer. That is, without the software, without system software, a computer can be termed useless. So also, system software executes immediately, like it starts working immediately a system comes on. That is, either be a cold booting or a warm booting. Immediately the system comes on, the system operation software starts operation immediately. And also there are some features of the system software which includes high speed. Now system software works very fast. If this can be seen in various computers. And how do you know this? Because the operations in which they are being performed on the system are very fast, and also it is hard to manipulate. If system softwares are very hard to manipulate in the sense that they are written in low-level assembly languages. Low-level assembly languages refers to like the first generation set of language, and trust me, these are very hard to come by. Like the developers or these language writers, which are also time developers of this kind of low-level assembly language, are very hard to come by. It's low-level computer language. It is close to the system. Now, system software, as the name implies, is system software. So definitely it is very close to the system, and it operates closely with the system compared to application software, which deals specifically with a specific task, compared to system software, which works or deals with all other tasks on the computer. So input and output system. System software deals with the input and output system. of a computer. For example, you trying to add an external mouse to your system. Now it is the system software that will actually validate if it's working, if it's like compatible, like the compatibility feature or the assets of the external mouse and your computer, to know if peradventure they are compatible. And also like the driver, that's also part of the input and output system. Now, to make this or to clarify further, there are some differences between system software and application software. Now, both are softwares, but then they have differences. Now, system software is a general purpose software. That is, it deals or it cuts across every application on the system. While application software performs specific tasks. For example, it can be you trying to install Spotify on your system. Now, this deals with application system because all you are trying to do deals with a specific application, that is a specific task. Also, system software is written in low-level assembly language. Like I explained earlier, it is very difficult to manipulate, while application system or application software rather is written in high-level languages. For example, application high-level languages like JavaScript, Python, etc. So these are high-level languages, and that makes application software easy to manipulate. That is, it can easily be manipulated languages. So also, it's cut across every other software on the system. While, like I said earlier, application software deals with only a specific application. So I hope with this it is clear enough. Like the differences between system software and application software is clear, and I hope there are no further contemplations on this. Thank you.
So having said all that has been said through my colleagues and I, we've been able to expound what enterprise architecture is. So we've been able to explain the fact that even if there is technology, infrastructures and all of that, and there's no strategy behind it, still it doesn't give an enterprise an edge over the other one. So before an enterprise architecture can be said to be enterprise architecture and reach whatever their goal is, it has to be centered on business strategy and information communication technologies. So we've been able to expound enterprise architecture, the component of hardware, the software, the hardware being the physical part, and the software divided into the application software and that of the system software. And we've been able to emphasize on the human input of all of this, because there has to be a brain behind all of these things. The technology cannot work by itself except there is a brain behind it, and that's what gives an enterprise competitive advantage over the other. Thank you.